80 words per minute for 10 minutes. 5 seconds more. Start. A tropical cyclone is a rapidly rotating storm system characterized by a low pressure center, a closed low level atmospheric circulation, strong winds, and a spiral arrangement of thunderstorms that produce heavy rain. Depending on its location and strength, a tropical cyclone is referred to by names such as hurricane, typhoon, tropical storm, cyclonic storm, tropical depression, and simply cyclone. A hurricane is a storm that occurs in the Atlantic Ocean and northeastern Pacific Ocean. A typhoon occurs in the northwestern Pacific Ocean, and a cyclone occurs in the South Pacific or Indian Ocean. Tropical cyclones typically form over large bodies of relatively warm water. They derive their energy through the evaporation of water from the ocean surface, which ultimately recondenses into clouds and rain when moist air rises and cools to saturation. The strong rotating winds of a tropical cyclone are a result of the conservation of angular momentum imparted by the Earth's rotation as air flows inwards toward the axis of rotation. In addition to strong winds and rain, tropical cyclones are capable of generating high waves, damaging storm surge, and tornadoes. They typically weaken rapidly over land where they are cut off from their primary energy source. For this reason, coastal regions are particularly vulnerable to damage from a cyclone as compared to inland regions. Heavy rains, however, can cause significant flooding inland, and storm surges can produce extensive coastal flooding. Though their effects on human populations are often devastating, tropical cyclones can relieve drought conditions. They also carry heat energy away from the tropics and transport it toward temperate latitudes, which may play an important role in modulating regional and global climate. The near surface wind field of a tropical cyclone is characterized by air rotating rapidly around a center of circulation while also flowing radially inwards. At the outer edge of the storm, air may be nearly calm. However, due to the Earth's rotation, the air has non-zero absolute angular momentum. As air flows radially inward, it begins to rotate cyclonically in order to conserve angular momentum. At the center of a mature tropical cyclone, air sinks rather than rises. For a sufficiently strong storm, air may sink over a layer deep enough to suppress cloud formation, thereby creating a clear eye. Weather in the eye is normally calm and free of clouds although the sea may be extremely violent. The cloudy outer edge of the eye is called the eye wall. The eye wall typically expands outward with height resembling an arena football stadium. This phenomenon is sometimes referred to as the stadium effect. The eye wall is where the greatest wind speeds are found. Air rises most rapidly, clouds reach to their highest altitude, and precipitation is the heaviest. The heaviest wind damage occurs where a tropical cyclone's eye wall passes over land. Worldwide, tropical cyclone activity peaks in late summer when the difference between temperatures aloft and sea surface temperatures is the greatest. However, each particular basin has its own seasonal patterns. On a worldwide scale, May is the least active month, while September is the most active month. November is the only month in which all the tropical cyclone basins are active. Environmental steering is a dominant term. Conceptually, it represents the movement of the storm with the background environment akin to leaves carried along by a stream. Physically, the flow field in the vicinity of a tropical cyclone may be decomposed into two parts: the flow associated with the storm itself and the large scale background flow of the environment in which the storm is embedded. In this way, tropical cyclone motion may be represented to first order simply as the advection of the storm by the local environmental flow. This environmental flow is termed the steering flow. A third component of motion that occurs relatively infrequently involves the interaction of multiple tropical cyclones. When two cyclones approach one another, their centers will begin orbiting cyclonically about a point between the two systems. Depending on their separation distance and strength, the two vortices may simply orbit around one another or else may spiral into the center point and merge. When the two vortices are of unequal size, the larger vortex will tend to dominate the interaction and the smaller vortex will orbit around it. A tropical cyclone can cease to have tropical characteristics in several different ways. One such way is if it moves over land, thus depriving it of the warm water it needs to power itself, quickly losing strength. Most strong storms lose their strength very rapidly after landfall and become disorganized areas of low pressure within a day or two, or evolve into extratropical cyclones. There is a chance a tropical cyclone could regenerate if it managed to get back over open warm water such as with Hurricane Ivan.